Okay, I guess this is probably the time to get going. So hopefully anybody who's late will catch up through the recordings. All right, so welcome to day number 4, which on a very good side is this is our last day we got here. Okay, perfect. Just give me 1 second. Okay, this one and at the top. Okay, here we go. Okay. Good, that's it. And I will check the list in a few minutes as well. All right, so as I was saying, this is a good day because it's the final day you have to deal with me. Okay, so it's only 3 hours away from being done. All right, now the really cool thing, however, is yeah, this is actually the stuff that we're going to cover today on tuples and sets. Okay, kind of important, but this one over here called Lecture 11 on basic dictionaries, and even the one after is nested data structures, that these are the most important things in terms of programming anything significant in Python. Okay. I know I keep saying that because lists are obviously important, but yeah, it's the list plus the dictionaries, and of course using functions. Those really are the most important things. If it was a case that I was comfortable that everybody had been doing programming like quite recently, like this was your normal or whatever, then actually what I would do is I would very quickly go through most of the stuff we've done and jump into here because this is kind of more important. All right, in any case, here we go. First hour is we have something, lecture number 10, about something called tuples and sets. Now, these are kind of funny things because they're not actually absolutely necessary in a programming language. Like, for example, the very first programming language I did a bunch of work in was something called Pascal. We had sets, and then they completely disappeared pretty much until Python. And in terms of a tuple, well, you just have other ways of dealing with the same type of thing. We didn't actually need tuples, but anyway, Python has got it, and unfortunately, okay, fortunately, sets don't show up very often. Okay, really, they don't. They show up like in courses, and that's it. However, tuples, on the other hand, actually do show up a little bit, and they do show up in existing packages. So, again, when you guys go off and look at your DSAI course, which I assume that everybody here will probably end up having to look at, you might actually end up seeing tuples. So it's probably worthwhile to at least know what they are. They're luckily they're not very difficult, but you have to be aware of like, hey, how come we're writing something this way? All right, so as a quick little bridge in introduction, so basically, if you were going off to do something, you're going off on a trip, there are basically three different types of options you could have if you wanted to bring some stuff with you. I would say the most normal thing that you'd bring is a suitcase where basically you can put stuff in, you can take stuff out, you can rearrange it so that more important things are at the top or at the bottom or whatever. All right, and of course, that's completely fine. And by the way, that is called a list. You can look at the list, you can put stuff into the list, you can remove stuff from the list, and you can shuffle around the order so that you can put more important things at the beginning or at the end, wherever you want. A second option, however, and sometimes we do this, if you go to the airport, you shrink wrap your box. And basically, once that happens, once you pack it, you can't do anything with it. You can kind of look and see what's inside, but you're not really allowed to do anything with it, of course, until you break the thing open. All right, so that's like the shrink wrap stuff. And then we have some kind of a bag where there are absolutely no duplicates. Now, might sound a little dangerous. I mean, okay. Um, Okay, sorry, I hate to say this would be stereotype, but okay, how many shoes do you bring? Okay, well, the answer to that's going to depend. It depends mostly whether they're not, sorry, mostly male or female. What I've noticed, and this happens in my own family, is I tend to like bring one pair of shoes, but the girls tend to bring multiple pairs of shoes. And maybe, of course, that's not very efficient, so maybe it's a bag where no duplicates are possible. The thing here called a sealed box, like once you put it in, you can't change it, that's actually a tuple. And the thing here, a bag where there's absolutely no duplicates, that's a set. And that's the reason why I wanted to include this quick little description of these things. All right, so let's get into this. So I am going to write a tuple. Okay, and I think what I'm going to do is I will more or less cover, let me clean up my screen a little bit. Okay. We're going to go back in and we're going to do something. All right. Reminder from yesterday. Remember, we had a bunch of test scores. I'm going to make this really, really easy. I don't want a list of lists because I think you probably realize that when you have a list inside a list, it's a lot harder to work with. And that is entirely true. A single dimensional list is obviously much, much easier. But here you go. Here's a bunch of test scores. And of course, there are things you could do. Something very important. You can definitely have two 78s and two 80s. In fact, you have three people with an 80. This is no problem. Things that you can do, of course, is, well, you can print them. Okay, that's no problem. You can print an individual item, scores at 0. Okay, there you go. There's the first two things. That's printing everything, printing the first one. If you wanted to switch around, say, the first and the second one, you know what? I can do that. Temp is equal to test scores at 0, test scores at 0 is equal to test scores at 1, and then test scores at 1 is equal to temp, and I'm going to print test scores. All right, when you see this, of course, what I've done is I've switched the first two things around. Perfect. So we can switch the order of things. That's what I was talking about. And of course, if we just don't like something at all, you can change it completely. So if we run this one final time, you'll notice, of course, I changed the first one. All right, so that's what I was talking about the suitcase. Yeah, you can do basically whatever you want. Oh, and we learned yesterday that there was an append for adding new values and a pop for removing values, or a remove. Okay, so that's fine. Now, that was a list. I am going to introduce you a new concept today. It's called a tuple. All right, first thing I'm going to do is I'm going to remove all of this stuff right here. Okay, I don't want to delete it because I'm going to put it back in a few seconds, but we're going to start with absolutely nothing. All right, we're just going to print it. All right, what you're looking at in front, here, I made that one step bigger. We are looking at a list. I can tell it's a list because it uses square brackets. Now, let me see. I got to remember which language it was because now it's been a really, really, really long time. But in any case, sorry, I can't remember for sure which one. But what I'm going to do is I'm going to switch this around to be parentheses. And very strangely enough, you say, okay, well, is that some kind of a problem? And if you run this, well, it looks like it's still working because I can see exactly the same numbers. The only thing that's different, instead of square brackets, I'm using round brackets. All right, well, hey, friends, this is called a tuple. Okay, now a tuple looks an awful lot like a list, and that's exactly what it is. It's a list, but it has one particular property. All right, first of all, let me uncomment this one. This line right here, line number 3, well, that will go and it will grab one value out of a tuple. That works exactly the same. Let me remove these statements because I actually don't need them. Because what I'm going to do is I'm now going to do this, and I'm going to do this. All right, so what am I trying to do on line number 4? I am attempting to modify the 80 to be equal to 100, and then of course we're going to print it. Unfortunately, what happens is when I run this, absolutely nothing happens. Okay, well, and then it's crashing, nothing happens. We end up with a crash. And it says here that tuple object does not support item assignment. And that happened to be on line number 4. So here you go. A tuple is just like a list, except you can't change what's inside. Okay, that's it. And really, if I wanted to, I could just call it a read-only list. Okay, but that's not what they did. They came up with a brand new item called a tuple, and it works exactly the same as a list. Like, for example, I could say for S again is my word, S for scores, in test scores, print S. Yeah, that'll iterate through. I can check other things. I can ask the question if 67 is in the test scores. Okay, then we'll print yes. Okay, and yeah, of course it is there. And if I ask whether or not 98 is in the test scores, well, it isn't, so nothing gets printed. In other words, it looks just like a list, except that you can't change it. And that's exactly what it's for. Okay, well, that sounds kind of pointless. Was it absolutely necessary in the language? And the answer is, well, no, not really. You just had to be kind of careful. But in any case, as I say, tuples are like lists, but they are immutable. No, something about immutable. It means you can't change the inside of them. Okay. But tuples are still ordered. They have fixed positions. There's a first element, a second element, a third element, a fourth element. You can iterate through. You can iterate through using a loop. You can use indexing to pull things out. Hey, can we do tuple slicing? I mean, does that actually exist? Here we go. Test scores from, let's say, 2 to 5. What do we get? Yeah, you can even do slicing on them. In other words, it has all those same things. I forgot to include slicing. So tuples are used actually using commas, but usually include the parentheses. Okay, what do I mean by this? All right, the parentheses are actually not required. Test scores. Okay, here we go. And what I mean by that is right here, clear the output, it looks like it might be a problem, but it's actually correct. The parentheses are absolutely not necessary, although I'm going to tell you most people, when they write a tuple, they always put parentheses. I do too. Whenever I use them, I always put in parentheses because it reminds me that it happens to be a tuple. But in reality, it's the commas without the square brackets that makes it a tuple. Okay, so just small piece of trivia. But my recommendation is just include these things. The list operations, other than modifications, still work. So if you wanted to use the in functions, as I showed you, you want to iterate over things, you want to use the index function to count function. Yeah, all of these things work. You just can't modify things. And you can see here that I've got the example where I've got this color as 255, 180, 30. For those who've worked on web development, you know what this means. And I just happen to have this as a tuple rather than a list. Did this need to be a tuple? And the answer is no, no, not absolutely not. This could have worked perfectly fine with a list. Okay, so there's one extra piece of information then that the parentheses are not mandatory. If you want to create a tuple with only one value, however, you do need a comma. So this one is a little bit surprising. Okay, so let me do something, a test score, and I'm just going to put 80. And I'm going to, oh, I guess we have to figure something out here. Print test scores and print type test scores. Okay, so now let's find out whether or not you remember type. Okay, so if I print out the type of the test scores, what's it going to tell me? Well, I sure hope that this comes out as an int. Okay, perfect. If I put a square bracket around it, okay, take a look at this. The type of the thing is a list. Okay, very, very good. All right, now I'm just going to put an extra one, 45. Okay, so there's nothing funny about this. Okay, that's a list. Sorry. There we go. That's with the 45. I'm going to put these things around as parentheses. And of course, what do we see? We see a tuple. Very good. What about if I only want one? Well, if you only want one element, you get this weird little problem because it just assumes that this is actually a parentheses. It's like you're trying to group it for arithmetic operations. Remember, it's not the parentheses that makes it a tuple, it's the comma that actually makes it a tuple. So you need the 80 with at least a comma, one comma at the end. That's what produces a tuple. And sometimes this can actually be kind of surprising. All right, so here we go. Now the question may become, here in the next page, is why would you want a tuple? Okay, so why did they include it? Well, I'm not the person who designed Python, so why people included it? Okay, I have some ideas about why they did. They probably used it when they wanted to make sure that data should never be changed. So you have a bunch of information, you want to call a function, but you want to make sure that nobody messes with it. Okay, so we better have an example of this. Okay, here we go. Def, compute, average, scores. Okay, how do you compute the average of a bunch of test scores? Well, pretty simple. You'd calculate the sum of the scores. Uh, you'd have a count called the length of the scores, and you'd return the total divided by the count. And I'll spell my name correctly right here. All right, and let's have a test scores. Okay, so let's assume that we have some really good students this time. Okay, so, well, we always have good students, of course, but compared to say last time that I typed up a bunch of really low scores, here we go. And if I said that the AVG is equal to compute average test scores, and I print AVG, bang, there you go. The average is 83.66667. Oh, by the way, if you only want to see, say, one decimal point, there's a function built in called round. I haven't covered it because it wasn't part of the reference, but here's how you round things off in case you ever need it. Now, a very important thing. If I print test scores, of course, I see exactly the test scores that were passed in. But remember, because scores happens to be a mutable item, a mutable object, when it gets passed into the compute average, if the average function either intentionally modifies the value or accidentally, and by the way, accidental modifications do happen quite frequently. You're trying to use a variable called scores, you forgot that was the name of the parameter. Trust me, this happens. Um, ooh, Okay, I'll hit that question. That's a really nice question. Thank you. Okay, do, do, because what you've got there is a little bit different. Colon dot Ooh, okay. You know what? That is a new piece of syntax I'm not entirely familiar with. Sometimes people add things, and of course, we don't cover everything. All right, I will answer that question in a second. Thanks for the question. All right, so here we go. Of course, what happens is, yeah, although somebody computed the average, it looks like the value of the scores was accidentally modified. Now, here's one of the things about this. If you turn this into a tuple, we're actually going to find out if somebody tries to modify this, because of course you're not allowed to modify a tuple. There's a good reason why you might want to use one of these things. In fact, here's the way how it would often be used is somebody would probably say, okay, instead of passing it as a list, I would like to pass it in as a tuple. All right. And of course, what it gives me the protection so that if somebody accidentally does this, at least it doesn't wreck anything. So by passing things in this way, I can guarantee my test scores won't be changed and I will get back the original ones. All right, now I've got a question about something that I'm actually not entirely sure about. All right, so let me close this one up because I think I might want this function back in a second. No, 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 no. Let's get this back in a second. All right. Um, all right, so the question that I've got is converted one. Round value, oh, there we go. Round value one, print converted one. All right, there we go. That's the one that I just showed. And in the chat, I've got something like this, and it's slightly different than I thought in the original place. I'm seeing value, value dot one F square bracket. Is that, yeah, you see, that's not it. Do you mind giving me just a little bit more of a context? Because you might be doing something that I'm just not expecting. Maybe it's closer to what I thought in the first place. Give me 1 second, because there's a slightly different way that I actually thought it was initially. Python. Do. Yeah, if you give me a full example. Okay, otherwise, just give me 1 second and I will come up with an example of what I think you're suggesting, because I don't think what you've put here is quite correct. All right, so off to my great friends. Ooh, okay, excellent. That's okay. This is what I was expecting. Okay, that's what I thought in the first place. Okay, so here we go. I'm going to do this. F, the result is convert it. Okay, there you go. That's my approach. Your approach was print F, the result is, okay, let's do it this way first, value. Okay, all right. And your suggestion was to stick, okay, and I'll be honest, I don't use this format very often, but a colon followed by a dot followed by a one followed by an F, okay, and let me show you what happens. All right, excellent. So this is what I thought you wrote the first place, and I thought maybe there was something else. All right, so this is actually what I was expecting. And the question is it better to do this? Is it better to do this? Unfortunately, I have to give you a very, very nasty sounding answer, and the answer is It depends on what it is that you're trying to accomplish. Okay, sorry, that's really all that it is. It really depends on what it is you're trying to accomplish. If for some reason you need to use the rounded value over and over again, this is the right way. This one right here, this is a way to display in rounded format. So I guess the real question is, would you do what you just suggested, or would I say round value one? Okay, which of course also does exactly the same thing. All right, so here's what I would end up using. If I needed to use the rounded value over and over again, okay, the stuff that I've just highlighted, two and three, that's exactly what you want. Otherwise, both of those are exactly the same. Okay, so which one do you pick? Whichever one comes to mind. Okay. Honestly, this one almost never comes to my mind. Okay. But that doesn't mean you can't use it. It just isn't something that pops in my mind most of the time. I usually like to write things out this way because I'm reminding myself this is rounding as opposed to displaying with one decimal point. It's whatever you want. So let's see the original question. Yeah, you use your method. Is it okay or is round better? And I'd say the answer is no. It just kind of depends. As I say, I use this one just as a reminder that I'm rounding it, but that doesn't mean there's anything wrong with this. You use whatever is the most convenient. My big suggestion that I have in the world of programming that I always tell my students, you will see certain ways that I do things that I ask students to do. There are sometimes ways that you can do things differently. The only thing that I kind of suggest is that you try to be consistent. Like, for example, right, using single quotes versus double quotes. Does it matter? No. Does it matter if you use a mix? Not really, but it's really helpful if you continuously do the same thing. Because if you always do the same thing, when you make a mistake and do something different, it really stands out. And that's that. I'd like to be consistent. So if you would like to if you'd like to use that instead of the rounding, that's completely fine. My recommendation is just be consistent and always do this. Okay, here's the one thing that this one might give me that this one would not. Okay. Ba, 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 ba. Four, count in range. Five, print value, round value count. There you go. And just for fun, we'll even go up a little bit further. We'll go up to 10. There you go. There's something that I can do that you won't be able to. Okay, not with the formatting. All right, but again, if you're used to using the other one and you need to do this, okay, you know what? Fine, break the rule for one time. All right, so yeah, I would say they're completely interchangeable with each other. Okay, hey, thanks. That was something unexpected. I like that. All right, so here we go. We've already done this one. So that's the first one is you want to make sure that the data can't be changed. All right, multiple values from a function. Ooh, okay, now. Okay, here we go. I need to come up with an example, and I didn't do a very good job. So I need to think very quickly of something that would give me. Okay, let's call it class size. All right, give a course ID. Okay, like maybe CP 2030. Normally what you do is you'd go and you would look up in a database for a bunch of this information. And there are usually two numbers associated with the class size. There's the regular cap, which we quite often put at 24, and then we have something called extended, which we might stick at 30. All right, here's what we use it for. So if somebody says, okay, how many students can we stick inside this course? You give two numbers. The regular cap is the actual capacity of the course, is what we're trying to gain. We're trying to gain like usually 24, 25 students. But sometimes you get some situations where you have a last minute addition. Somebody has to take this course because they got some work commitment and they have to put in your class and you have to extend it. All right, so what's happened is normally you would look this up in a database. So we don't have a database here. But if I've got these two numbers and I wanted to return the two numbers, how can I do that? You see, I can return the regular cap. So if I were to come down here and say class size, and I gave CPIT 1020, bang, bang. Okay, it comes up with 24. And of course, if I want to return extended, it's no problem. Return extended. What if I want to return both? Okay, well, unfortunately, if you want to return two values, regular cap and extended, you're only going to get back the regular cap because as soon as you hit a return, just like every other programming language, the entire thing is finished. Unfortunately, what you need to do is you need to turn this into some kind of a new structure. There's a couple of different structures that can be used. One of the most popular methods that people use when dealing with returning more than one value from a function is they use tuples. And here you go. That's exactly what you do. You can see it looks like a tuple. Now, so I'm just going to call it cap. Okay. Oh, you know what? Yeah, I'll call it cap. And if I say cap is equal to class size, CP, it doesn't really matter, print cap. Here you go. Here comes back as a tuple. And of course, if you want to see the actual capacity versus the extended capacity, you can use a 0 and 1 to pull these values out. There's one small little kind of cool trick, and I have to show you because sometimes you will end up with functions that do return more than one thing. And this is the regular, and the second is the absolute max. Okay. I've got this really cool little trick. If you say one variable, so here you go, regular, comma, absolute max, you can actually pull out those two values independently of each other. Okay, so rather than getting back a tuple, what you're doing is you're doing an operation here called unpacking. All right, so did we say that? We should have said that over here in the slides, and if not, there we go. No, it didn't actually say. All right, so we do use it as a return for multiple values from a function. It can be used as a key in a dictionary. Sorry, I don't have an example of that one, but a lot of libraries and APIs actually require tuples. All right, so for example, if I was trying to access something from a MySQL database, I may say select star from students where ID is equal to, and this particular PyMySQL, go back to here, this actually uses tuples. So you have no choice. You have to use the tuples. Yeah, the is the parentheses required here? And the answer is yeah, actually it is required this time because if you leave the parentheses out, the interpreter gets confused thinking that the comma is part of the cursor.execute. Okay, so the parameter is it's a string. And what happens is this thing right here gets replaced in as the %s. Again, way outside the scope of this course, but something you have to be aware of because a lot of functions in existing libraries either expect tuples or they return tuples. Here we go. All right, so there we go. That's tuples. Really useful? Okay. They didn't actually need it in the language. They could have used lists. Okay, really, they could have used lists. Even for executing cursors, it could have been list. For returning multiple values, it could have been list. So I consider it kind of a time waste that it's here, but unfortunately, a lot of people have gone this way and they have APIs that return tuples. So I have no choice but to cover it. All right, we move on to something also that isn't absolutely necessary, but it does have some really cool things. Okay, here we go. Now, do I have do. Okay, during the break, I've got a really cool example, and I don't think it's in my slides, but I will try to remember to pull something up. But in case, here we go. A set. Okay, all of you would have gone through at least a math course a long time ago, and you would have ended up talking about something called a set. Okay. All right. So what's a set? Well, a set is a whole bunch of values, or well, in the case of Python, it could also be it could be numbers, it could be strings, and so on. But a set is simply a collection of things. And of course, if I were to bring up some diagrams, here we go. Set Venn diagrams. Immediately, when you start to see the pictures of these, you'll go, "Oh yeah, those things." Okay, and yeah, that's exactly it. So you have a bunch of operations such as the intersection, the union, the subtraction when you take something and remove another, the complement, and so on. All right, so the people who designed Python decided that this language could benefit from having a set. All right. It wasn't absolutely necessary, but well, they've done it. And because they've done it, now I have to cover it. So luckily, it's not really difficult to deal with, but it has one really, really important property, and that is a way to get rid of duplicates. Okay, so no duplicates are allowed in a set. So here's what I'm going to do is I want to go back to my original problem. Let me font size here, this one right here. Let me control Z for a couple of minutes because I'd like to see my list of test scores. Okay, I'm going to write up the test scores. So here we go, test scores. All right, remember we had some 70s, we had an 80, we had a 90, 95, we had another 90 and 80. Get rid of those decimal points. I don't want those. That's just my finger stumbling. All right, and a 75. Okay, here we go. And if I print the test scores, it's not a big question or not a big shock. I will see 1, 2, 3, 4, 5, 6, 7 items. Okay, and they appear exactly in the same order that I typed them in. That means an ordered set. If I turn it to a tuple, it's also not a big deal. I would now like to describe this using a curly brace. Okay, so for those in PHP, Java, JavaScript, C++, yeah, all the languages, this is this type of stuff that we use for if statements and while loops and function declarations. Yes, it is yet another type of enclosure. Okay, in this case, I would just refer to these as the curly braces, and I'm going to run this. This is actually valid Python syntax, and here we go. This is what it looks like. Now, a couple of very interesting things have happened here. Do I see the numbers that I've typed? And the answer is, well, sort of. Okay, I sort of see them, but it looks like some things are missing. Okay, like for example, over here in the original test scores, I had I had two 90s and I had two 80s, but over here, when I printed this out, I only had 180 and I only had 190. Yeah. Okay. So guess what this is? This is how you denote a set. Okay. So you use curly braces to denote a set. Unfortunately, you also use curly braces to denote a dictionary. So there's going to be a couple of times where things won't work. But for right now, the curly braces mean set. All right. And of course, the rules about a set is you can't have any duplicates. So if you attempt to put a second 90 in here, it just gets ignored. Okay, or you could even say that it replaces the first one. It doesn't really matter because it's only got one. The second 80 that tried to get put in, well, it also gets ignored. All right, that's the first thing. Next thing up, if you take a look at the order that I defined the values in the set initially, and you take a look at what got printed, you'll notice that it is very, very different. Like, for example, I listed 70 first, but when I printed it, 70 came out second. I printed 80 next. I mean, there's another one later, and it showed up first. The 75, which was listed at the very end, ended up here between the 90 and the 95. It's completely gibberish. It's completely unpredictable. And in other words, is what's happened. All right. Remember, I told you that lists and tuples were ordered collections. A set is an unordered collection. There's no guarantee about what ends up happening. Okay, so back over here to my slides, it says right here, a set is an unordered collection of unique elements. So it means that there's no guarantee. You put 1, 2, 3, 4, 5 into a set and you go through and look at it, you might get 5, 1, 4, 2, 3, and you look at it again, it might be something completely different. There's no guarantee. Now, the one thing that I will tell you about sets in the world of Python is once you put everything into place, usually they don't tend to bump around, but there's just no guarantee of it. Okay, so that's just something to watch out for. So here we go. No duplicates are allowed. You create a set either using the squiggly brackets, curly brackets, or you can type the word set followed by parentheses, and you can pass in a list. And it will convert the list into a set, and it will get rid of the duplicates. The order that things show up in, nobody actually knows. All right, so why on earth do you need to have sets? Okay, sets are really useful for getting rid of duplicate values. So I always have an example that I keep talking about over and over again in my regular course. So it's all right, I'll use that one. And here's what I use it for. Okay, I would like to write a small attendance taking system, and I am going to pretend that I have students whose ID numbers is 6001, 6002, 6003, all the way up to 6099. Okay, so we have a bunch of students in a course. And we'll suppose that there's 100 of them. And one of the things that I have to do is I have to take attendance each day. That's during the regular semester, excuse me. And of course, well, what I want at the end is a report saying who was here. All right, so here's what I'm going to do is I'm going to write a program that asks the user to type in the IDs, and we're going to hang on to the IDs. All right, here's my first one. So I'm just going to call it attended. And I'm going to have an empty list, not a set. I'm going to have an empty list. We'll turn this into something else in a little while. And basically, I'm going to have the following. I'm going to ask for a STID. That's a student ID. This is me being lazy. Here we go. Stu ID, and I'm going to say int student IDs. Are the ints? Okay, fine. They're ints. Input, enter who came in the door. Okay, and I'm just going to say while stu ID does not equal to -1, that's going to be my sentinel value to stop everything. And here's what I'm going to do is I'm going to say attended.append stu ID, and I'm just going to ask exactly the same thing once again. All right, and then at the end, here are the students who attended today. Okay, so there's a real life problem, and I'm just going to print out attended. Okay, we'll run the program. Who came in the door? 6023 came in. Then 6051 came in, because of course I don't know who's coming in when they come in. Maybe somebody was late. 6001 popped in a little bit later. Maybe 6098 popped in a little bit later. And you know what? That's enough. And that's all the students that came in today. 4 students out of 100. Trust me, sometimes it happens in university. All right, -1, I stop, and here's a list of students. Perfect, that's exactly what I want. It's the list of students who entered. However, here's sometimes what happens. Okay, I started the class. Student 6053 came in. 6001 popped in. 6045 popped in. 6053 popped in. What happened? Well, they came in, they went outside to chat with a friend, came back in and scanned their card again to show me that they were there. And then, of course, a friend also did exactly the same thing because they had to go see somebody. And here we go, 6009, and we'll stop it right here. Now, this is a valid list of students who did attend today, but that's not very helpful to me because if I'm trying to put it into a system to say who's here and who's not, the 6053 and the 6001 both got duplicated. And yeah, we really don't want that happening. 6001, 6045. I'm just going to mark down who came in so I can do exactly the same thing again. Here we go. All right. That is the problem with a list. Okay. I mean, it works perfectly fine, but I want to repeat this using a set. Now, if you want to have an empty set, this is actually not the way you do it. This creates something called a dictionary, which we'll see very, very soon. This is the way how you create an empty set. And what I'm going to do instead of appending, yeah, you can put stuff into a set. The operation is called add. Okay, it looks exactly the same. Where does it put it? Well, it doesn't matter because sets are unordered. So you don't use append because append says put it at the very end. And of course, that's not what we're doing. Okay, we're talking about simply adding something to a set. Now take a look at this. I'm going to run the same thing. We had 6053, 6001, 6045, 6053, 6001, and 6009. They came in and a -1. Well, here you go. Those are the students who attended today. Knows what it's done? It got rid of the duplicates. Because whenever you try to add something, if it's already in the set, then it simply gets ignored. Okay, so it's a very convenient way of finding out unique things. Okay, and it really is helpful. Okay, and this is the reason why you might want one. It's very good for tracking groups of unique items like student IDs and tags and so on. Sometimes you might want to do some really, really cool things. And I guess what I'll have to do is I'll have to put together Do I have an example of this? Oh, I've got the example popping up. So I won't bother doing it right now. I'll wait till I get there. We'll copy and paste the code just so it doesn't take too much time. Um, and it's also really good to determine if something is present very quickly. Okay, so what does this mean? All right, so here's what I'm going to do. Ooh, not that one. Let's see. Take this one, copy. There you go. Print. Okay, 6009 in attendance. Yes, it is. Okay, yeah, and you stick this inside an if statement. Okay, now here's what I'm going to do. I'm going to turn this into a list. Ooh, okay. And I'm going to say print 6009 in attendance list. Bang. Yeah, it works exactly the same way. Okay, now the difference, however, is this is actually considerably faster for the computer than this. Now, unfortunately, my little example here is so small that you would never believe me that this is actually happening. So you'll have to give me a little bit of time. I just have to open up one of the other slides. So what I'll do is I will do that during the break, and then I will demonstrate that there's actually a really big difference between using sets versus using lists. But I'll have to do that. It'll take a couple of minutes. It was supposed to be added to the slide set, but I don't think it's here, which is really too bad. Unless I'm really lucky. Okay, no, I don't see it. I don't see it at all. All right, so what I'll have to do is I'll pull it up from my regular course. Okay, we'll pop it in. All right, so as I said, it's a really good way of getting rid of unique methods, or sorry, getting rid of duplicate things so that everything is unique. All right, the methods that we have, stop it. I don't know why the mouse did that. All right, here we go. The methods for dealing with sets. Yeah, there's a dot add. It's kind of like an append, except you don't specify where things are. There's a remove where you give an item and it goes and it removes it. There's also one called discard, which is kind of weird because it removes an element, but if the element isn't there, it doesn't crash. It just kind of ignores you. That's useful. And the dot clear removes all the elements. I always include this, but to be honest, nobody ever uses it. We never covered it in the courses. The length function, of course, will tell you how many items are in a set, and the in operator works exactly the same as a list. So those are pretty reasonable. All right, there's also a bunch of really, really bizarre operators in here. They're the set operators. For example, if you think back to your days of math, you would have learned about a union, an intersection, and a difference. And of course, this is exactly what these are. What I'm not going to do is I'm not going to demonstrate the code, but I will talk about each of these operators. Okay, so here we go. Suppose you need to know if all the students is in a pair of courses. A good way to do this is to do something like this. So for example, if I had comp 1001, here's a list of students, and comp 1002, and I really wanted to know who was in, or all of the students, because I needed to send an email to all my students to say, hey, tomorrow, Tuesday, class is going to be canceled or whatever. I would want to send everybody an email message across all my classes. And using the union is a very good way to do this, because what will happen is it will get rid of any of the duplicates. So for example, 60301111, 60301111, this person will only show up exactly one time. So it would show up in my email message just once. Sometimes you want to know who's taking multiple courses. Okay, so here we go. I want to know who's taking both courses at the same time. This is called an intersection. And for the intersection, I use something a little bit different. I use a dot intersection rather than a dot star, I think is what we use. I have to turn back 2 pages to find out. And of course, what this is, the intersection will show you the things that are exactly in common. Well, I suppose what I could do is I could copy this. Bang, here you go. Those no, that says only in comp 1. It's actually, oh, sorry. I flipped over a page. I got the difference. Ignore that, ignore that, ignore that. Here, bang, here you go. There we go. So there's the intersection. That's the list of students who appear in both of these things. Yeah, you could obviously do this by hand, but why would you want to? Oh, okay, you see there's a question over there. Okay, let me finish up my next operator. There's also something called a, uh, a difference. And of course, what it does, here, we'll take this one. Okay, so here's the difference is comp 1001 minus comp 1002. And what I'm asking in this case is give me a list of students who are taking comp 101 who are not taking comp 1002. All right, so for example, 6030353456, that you will find up here, but you won't find it in this one. Okay, and that's what we use sets for. Okay, now that's sort of the theoretical background. Okay, so how many times do I use this? I always like to bring this up. Do I use sets on a regular basis? All right, I'll be honest, I don't use them very often. I've used them before for dealing with attendance. I've actually done exactly the same type of thing. I had an attendance system that I would mark things down. Um, do I use it for others? No. If I can't even think of one of my examples that I have in PyCharm that I would open up and I say, hey, look, I use the set for this, because really I don't use them that often. Every now and then, if you needed an intersection, maybe I would use a set, but to be honest, I don't find that they're all that useful. However, I've got to include them because you never know. Sometimes you get stuck into a library and as a result, you might have to end up using them for one thing or another. So that's really the only reason why we still cover them. Now, I believe that I still have a couple of extra things. Okay, you know what? Let's go through. Oh, okay, so the question that's popped over here is, can you union a list and a set or a tuple? Okay, very good question. And I think it ends up working really well for what I just put right here. Okay, excellent. So you had some foresight to ask a really, really cool question. All right, so here's the deal with a union, intersection, and set difference. Okay, so here we go. The ampersand is for the elements that are common. Okay, so here you go. That's an intersection, A intersection B. All right, let's do this because the question is essentially like this. Okay, test one scores. Oh, okay. Um, yeah, test one scores. Okay. There was a 70, there was an 80, there was a 79, and there was a 70. All right. Test number two, I had the following scores: 60. I had an 80. I had a 23. Let's see, so a little different, and a 71. All right. Do I have anything in common? Okay. I made it really simple to see. The 60 and the 80 are exactly in common. Uh, just so it's a little bit different, let's stick it up here. All right. I have those two things in common. All right. You see, the thing is that if you take test one plus test two, which by the way happens to be the set union operator, yeah, it just puts everything together. But of course, we're not dealing with duplicates. Could I then turn it into a set? The answer is yes. Now, we're talking about, can we do things like this? And the answer is not directly. But what I can do is I can easily convert from one type to another. Okay, for example, if I really want to have a set for test one, that's what the test one set would look like. If I really wanted to have a set for test two, that's what the test two set looks like. If I wanted to calculate, say, the test one set of values ampersand intersection with test two sets, that's how I would do it. So you can't union a list. You can't union a tuple, but you can easily turn tuples and lists into sets and vice versa. Okay, so all of these things are very, very nicely convertible. So here we go. Here's the list of students who were present. So here's the students attended. 10 did. Okay, so we had a 6001, a 6007, a 6034. Here you go. And of course, students attended. Yeah, students attend. I have to spell it correctly and the same way. Okay, consistency is more important. All right, could I turn that into a list? And the answer is yeah. Student list is list of students attended. Bang. Okay, and we will print the student list. Bang, and there you go. There's a list with exactly the same things. You want to have it as a tuple, no problem. Turn it into a tuple. There you go. There's a tuple of the students who attended. The good news is that everything is very, very flexible. You can go from one type to another without an issue. The only thing that you have to watch out for, of course, is that if you have a list and you turn it into a set, all of your duplicates will be removed. And then if you turn it back into a list again, well, now it's a list, but without any duplicates. That's the only thing you have to watch out for, but it's easy to convert between one type to another. So the answer, can you union a list and a set or a tuple? The answer is not directly, but it's easy to turn into whatever format that you need. Okay, so at least they've made that pretty easy. All right, so here we go, converting. So very, very simple. Yeah, all you do, this is called a constructor, by the way. So those who've been through object-oriented programming in Java and C++, these are basically constructors. And yeah, you just say list, tuple, or set, and we use it all the time for removing duplicates, making a list immutable, or changing it to some other format so that it can be used by a library. And I do that quite often. Sometimes I have to turn something from a list into a tuple because my MySQL request needs to be in the form of a tuple. So it's pretty easy to switch back and forth. Okay, the source tuples versus sets is just what if they're orderable, mutable, et cetera, et cetera. Oh, 52. Okay, so actually, I guess I've gone over a couple of minutes. All right, well, what I'm going to do is same thing that I've done before. Let's pop open a countdown timer for 10 minutes. And while I'm here, I will, or while I'm on break, I will go and I will pull up my one really cool example. So a 10-minute timer. Okay, here we go. So there's our 10-minute timer. So when it reaches 0, I will stop up again. Okay, see you in 9 minutes and 50 seconds. Boom. Okay, and I don't need to hear this siren. Yeah, that's it. Okay, out we go. Right. Give me a second. Okay. Took me a little longer to find what I was looking for. I had to make that a little bit more obvious. All right, but here we go. Sorry, I've got a kind of a big program to show. Just give me one second. Oh, sorry. Get a little bit of a big program to demonstrate. So sorry, just bear with me while I explain it. All right, first thing up is, yeah, I'm using some random numbers so I don't have to type things. And I'm also using a package called time. Now, you can see here what I've got is I've got one function called create list. And what it does is it starts off with a list and it goes through and it basically adds n random numbers between 0 and 4 billion. So in the end, you have a really, really big long list of numbers. I've got another one in here called create set. And what I do is I start with an empty set and I go through and I add a whole bunch of things into the set. That's it. I've also got a function in here called find value. And all that I do is I'm just using the in operator and I'm saying is X in D. Okay, just is the thing that I'm looking for inside. Now, what I wanted to show you, the main program, at the moment, I create a list with 10,000 items. Okay. And what I do is I start a timer. So this is like starting a stopwatch. And all that I do is I go through 100,000 times looking for a random value. Okay, that's it. I print out some messages just so I know that things are working, but basically what I'm doing is I'm going through 100,000 things looking for random values. If I find it, I increment. If I don't find it, I increment a different counter. I'm not actually caring whether or not I find things, but what I'm interested in is how much time does it take to find something 100,000 times in a list of 10,000 items. Okay, that's all that I'm doing. And of course, what I'm doing is I'm creating this as a list. This is currently commented out. So you go off and you run it. Now, obviously, it's going to take a different amount of time depending on how fast your computer is. So the computer that I've got here is pretty quick. All right, but still, because I'm repeating the operation 100,000 times, okay, we're almost there. 10,000 and 100,000 done. And you can see it comes up with 16 seconds. Okay, so it took my computer 16 seconds to basically do 100,000 searches looking for this. Obviously, faster than anything that you or I can do, but that is a list, 16 seconds. Now, what I want to do is I'm going to comment on this, and instead, I'm going to create a set. Now, remember, the difference between a set and a list is the curly braces, as well as, well, of course, the no duplicates. It isn't the fact that it's a no duplicates, but because it's a set and sets are implemented very, very differently in the world of Python, they tend to be a little bit quicker. Like, for example, all I'm doing is I'm just creating this as a set. Take a look what happens. Yeah, you can see that that was pretty much quicker, wasn't it? Yeah, 0.1 seconds as opposed to 16 seconds. It's really, really quite different. And there was a claim that I had saying that if you're looking for things really, really quickly, you can use a set to help speed things up. And that's what I've done. Now, you might say, okay, well, it's not going to be that often we have these types of things. Actually, yeah, it does actually happen, say, on big servers where you have a lot of people searching for things. Yeah, it turns out that if you have things as a set, yeah, you can actually do it much, much faster. Now, that doesn't mean that everything should be turned into a set. However, usually what you end up using is use something called a dictionary, and it actually works exactly the same way as a set. Also, you can't have duplicates. Okay. All right. So that was the one I wanted to include as a small example to say that, yes, there really is a big difference between sets and lists in terms of performance. Okay, let's clear this one up. Oh, yeah, that was my test scores from yesterday. Oop, here, I'll close that one up. So don't worry, those are not your test scores. Okay, give me a couple of seconds while I clean up my stuff. Normally I do this during the break. Okay, so that one goes, this one goes, and over here for the second group. Okay, lecture 11. Okay, so good news is we're down. We only have 2 more hours to go, or slightly less than 2 hours. All right, lecture 11. I've said this many times. I know there's many things that I think are really important, but dictionaries in the world of Python are actually really, really important. Okay, because almost everything that you end up working with in these big libraries and the data science stuff, almost for sure you're going to have dictionaries. Okay, so I wish we had like more time because I can only do a couple of small things with dictionaries, but they really, really are very, very important. All right, so let's take a look and see what a dictionary is. Okay, so a dictionary is a collection of key value pairs. Hmm. Okay, key value pairs. The key is like a label or a name. The value is whatever the data is you want to store. Now, I suppose what I should have done is I shouldn't have done this. Okay, let me put this back for a second. Now, again, I'm not making anything up. I'm just going to randomly pick something. Okay, one student. I think it was the same student I picked on last time. Okay, yeah, sorry, keep picking on you. I wanted to leave out one test score. Okay, from this table right here, it's very clear which test score is missing. Okay, it's completely clear. I want to now go back to my Python code, and I'm going to put in all of this data once again. Let's put it right here. Okay, remember I had this thing called scores, and we had this problem yesterday. 90, okay, 97, 170, okay, 60, 89, 170, 78, 180, and 90, 80, 180. And finally, I know I got a decimal. I'll fix that in a second. 96, 100, 190. Okay, let's get rid of this decimal because that doesn't make any sense. Okay, here we go. So based on this information right here, we are missing a lot of information. Okay, first of all, we don't know who these students are who have the scores. Okay, yeah, I've got it listed down here in the table so we could easily recreate it. We talked yesterday about including person's name at the beginning, but I said, it's kind of gross because you have to constantly extract things. Okay, but that's fine. You can certainly do that. But the fact that this one right here, this is actually probably the most difficult problem that I've got to deal with. I know that student number 012, student number 2 is missing a test score, but I don't know if they missed test number 1, test number 2, or test number 3. I can tell right now they missed all 4. That's no problem. But when you have this, I know they missed one, but I don't know which one. And if that's important to you, keeping something as a list of lists is not going to work. Okay, so here's what I'm going to do is I'm going to show you a better way to store this information. Okay, so here we go. A dictionary is a key value pair. Okay, so what I'm going to have to do is I'm going to have to start with something very simple. All right, student. Now, dictionaries use curly braces. Okay. Oh, just like sets. It's sort of just like sets. That's actually the reason why you can't use this to represent an empty set is because it actually is used by a dictionary. Normally, I format things like this. You can put them in a single line if you want to, but normally I put them this way. All right, the very first student. Okay, fine. So what do we got here? Here's at the very bottom of my screen, I have exactly one student. All right, and who is it? Well, that student has a name. Their name is Abdullah. They have a test one. On test number 1, they got a 90. On test number 2, they had a 97. On test number 3, they had a 100. And on test number 4, they had a 70. All right, so if you're looking at this and you are coming from the world of JavaScript, you're looking at that saying, ooh, it's a JavaScript object. Yeah, this is exactly what you would end up doing. Unfortunately, the format is a little bit quirky inside here, inside the world of Python. Each of these things right here, the names, the key, has to appear inside quotation marks. Okay, that's the only thing I don't like it so much because I hate having to use quotes for everything. But there you go. That's called a dictionary. All right, now I'm going to show you what one looks like when you print it. Pretty exciting, right? All right. Now here's the nice thing about a dictionary. You see, if, for example, Abdullah doesn't write a test, it's really clear to me what test they missed on. So what I've done is not only do I have the values, I've got a descriptor about what the values mean. And having the descriptor about what the values mean is going to make the programming considerably simpler and easier to read. Okay, so this also goes by the way by name of a map or a hash table or even an associative array. For example, if you've come from PHP, you would have probably seen associative arrays. C++, you don't have one. Java, you don't really have one. But what you do have in C++ and Java is you have basically classes. And that's essentially what we've got here. In fact, the first time that I saw Python and I saw one of these things, I said, oh, okay, this is the way how you keep a record of information. All right, so what it is, it's a name followed by a value. It uses curly braces like a set, but he uses colons to separate the items between the keys and the values. So in terms of a real world analogy, basically you would use dictionaries, of course, to look up words. All right, well, let's actually create a dictionary. Okay, here we go. Create a dictionary. Now, unfortunately, what are we going to do? All right, so here we go. Computing acronyms. Now, let me see if I can come up with some computing acronyms and we can actually make use of this. All right, the letters CPU stands for what? It stands for a central processing unit. All right, RAM. This stands for random. Oh, and by the way, single quotes, double quotes, doesn't matter. I'm trying to be consistent. Random access memory. Okay, let me see what else I've got. PS, not a power station or PlayStation. This would be a power supply. Okay, maybe just one more would be good. Let me think what I can stick in here. IP. IP stands for Internet Protocol. There you go. So there's a dictionary. That's exactly what you use it for. All right. Now, obviously, printing a bunch of acronyms. Acronyms. Here you go. Of course, you have to computing acronyms. Computing acronyms, and you have to spell it correctly too. Wow. Here we go. Perfect. All right. Obviously, the output from this is kind of silly, but here's what I'm going to do. I'm going to ask the user to enter an acronym. Okay, so request input, enter an acronym. Okay, now here's what I'm going to do with the request. You see, I can go to computing acronyms, and what I can do is I can ask for one particular thing at a time. Let me do it hard-coded first. For example, if I ask for .cpu as a string, here you go, you print it out, it gets central processing unit. If I ask for IP, I get the Internet Protocol. Instead of hard coding them, what I'm going to do is I'm going to use this variable request. So enter an acronym. Which acronym? How about REM? Bang, there you go, random access memory. We'll run the program again, IP, Internet Protocol, CPU, central processing unit. So you see what it does is when you give a location like this, and you stick in some kind of what's called a key, it will go into the dictionary, it will find the item, and it will return the associated value. Okay, so this is what you use an actual real life dictionary for. I should include this one. We could also use a student record ID information. That's perfect. Or some kind of an item name we can stick in prices. And again, I believe I might have an example of this coming up, so I won't bother hitting this one yet. But there you go. There's actually using a computer dictionary like a dictionary. Now, could I do this with a list or a tuple or a set? Maybe, but it would be a whole lot more challenging to work with. Okay, this is actually really simple. The only thing where things are going to go really bad is if somebody shows up and says, okay, I've got an MUG acronym and I have no idea what it means. Unfortunately, because the key doesn't exist in the dictionary, it just blows up and it fails with an error message. Okay, let's get over to here. So accessing, updating, and adding information. Okay, so you use the square bracket to go and access the values. Okay, so I showed you this already. It's really useful when you have variables, but if you don't have variables, fine enough, print computing acronyms, okay, and dots, or sorry, at position CPU, excellent, pretty simple. All right, all right, adding values. Oh, yeah, okay, you want to add something new. Okay, so how do you add something new? Because remember, we've seen things like this. We've seen I should have picked something better. Acronyms. All right, I had an append. Okay, no, there's no append. Okay, we had dictionaries, okay, and it had, or sorry, sets, and we had an add. No, it doesn't work this way. Instead, what you need is, well, I need to come up with something, so give me a second. Um, okay, Mr. ChatGPT, give me some acronyms for computing. Okay, and I bet it's going to give me CPU. It's going to be the first thing. Oh, the world of ChatGPT. Okay, let me think here. What can I do? Okay, I will make something up. All right, so in the world of computing, does anybody know what the letters DB stands for? Well, typically we would probably use it for a database. Wow, that's taken a really long time. CPU. CPU is the first one it gave me. GPU. Ooh, okay, that would have worked. All right, a GPU. Okay, everybody knows GPUs because those are the things that you play games with. If I want to set the GPU equal to a graphics processing unit, this is what I do. Graphics processing unit. All that I do is I simply say square bracket is equal, GPU is equal to, and once I do this, if I print all the computing acronyms, okay, you'll now see that a GPU has been added. Pretty straightforward. All right, so then it came up with RAM, it came up with ROM, SSD. That one I should have thought of. Anyway, that's all right. It's finished now. So adding something new is very simple. You basically just say, hey, the dictionary at a given key is equal to this. What happens if I overwrite this? Like, what happens if I say PS is equal to graphics processing unit? Well, if I do that, well, first of all, it's a mistake, but what it will do is it will actually change inside the dictionary what PS stands for. Now, that would be a really bad mistake, but yes, it's pretty easy to update and to add things. Removing things, okay, so here's the way how it works. If the key is not the dictionary, it'll be added. Okay, so you saw that. And if the key does exist in a dictionary, it'll simply be updated. The only thing that can be a little bit bizarre, of course, is, as I showed you already, if you ask for ABC, sorry, square bracket, you'll end up getting a key error. Okay, so before doing something, you have to find out whether or not ABC is in a dictionary. How do you determine that? Exactly the same thing. So you can say if ABC is in computing acronyms, um, you could print this. Otherwise, you could print out a message saying, don't, I'll just say don't know. Okay, just something a little bit more polite. All right, and if you try writing this, it just comes up and it says, yeah, I don't know. Okay, but obviously you'd combine this with asking the user for something. All right, so there you go. There's kind of a really clever little thing that you can do with dictionaries. This is one thing that we do use dictionaries for. Like for example, okay, let's turn this into something a little bit more interesting. Okay, so somewhere on here, I've got a list of your IDs and your names. Okay, so what have we got? 60319953. That student's name is Abdullah. Okay, here we go. 60318960. This is Fatima. Okay, 60319999. Hey, that's a cool ID number. This is Dana. Okay, one more will be enough. This one right here, 60079061. And this is, yeah. Okay, excellent. So here we go. All right. We want to know who's present today. Excellent. But I also want to print out the names of the students. So here's what I'm going to do. I'm going to ask for a student ID, stu ID. I'm going to ask for an integer of a student ID. Oh, Wait a minute. I'm supposed to have IDs here? Oh, this is one of the problems with dictionaries is, yeah, we're actually, do. Oh, are we okay with this? Just give me 1 second. Bang. Yeah, if these are just integers, it works perfectly fine. You don't need to turn them into strings. A word needs to be turned into a string, but numbers can be just numbers. Okay, here we go. Stu ID and um, int input, enter ID, bang, bang. And I'm just going to say, well, stu ID does not equal to -1. So you know what I'm going to do? I'm going to repeat this over and over again until I put in a -1. And then I'm just going to say that the program is done. All right, but here's what I really want to do. I want to go and find the student's name. So how do I find the student name? Well, what I do is I go to, oh, the student list. Well, the students. I go to the students and I go to the stu ID. That gives me the student name, and I can just say that student is and student name. There you go. So student ID. All right, so let's pick one up that I've got in here, 600796061. Bang, student ID. Student ID. You're probably yelling at me. You're probably making fun of me. Turn hiding on. Okay, let's try it again. 600796061. Bang, perfect. I got exactly that student. 60318960. Bang. Yeah, you see, this is really, really cool. 60061234. Crash. Whoa, that's not what I want. This is what I was saying. Before you use this, how's the program finding? Okay, we'll get to that. All right, so the only thing that I really need to do is I need to find out if stu ID is in the students, then we're going to do this. Otherwise, I'm going to say student not found. Here you go, 60061234. Student, what did I do? What did I do? Students. How to spell this correctly? 60061234. All right, student not found. Perfect. 60079061. Now we're finding it. All right, so I managed to make somebody sort of wake up and go, hey, how is the program finding the IDs? All right, so we don't worry about how things work in an intro course like this. What we end up doing is you would normally cover this in a course called Algorithm Analysis and Data Structures. But given that we don't have it, here's what happens. Um, when you create a dictionary, IDs are put into memory locations that are going to be well known. For example, this will be put into a certain memory location, this will be put into a certain memory location, so that when you use the square brackets, it will jump directly to that memory location and pull up the information. You see, we have been doing things kind of like this before. We had a bunch of test scores. All right, what test score does this give me? It gives me the test score that's at position 70. Okay, the difference here is rather than having 0, 1, 2, 3, and so on, the keys are 60319953, 60318960, 60. So these are used as the positions. I use it very, very loosely. You could think of it, even though it would be incorrect, you could also think that when you're looking up values in a dictionary, it goes through each of the items till it finds what you're looking for. That's not entirely how it works, but you could think about it this way. It's actually very, very quick the way how it gets there. It jumps directly and it says, you know what? The key happens to be there. That's the name of the student. So it's actually really, really clever. It's a really nice way to be able to find things quickly without having to set up a loop to look for things. Because I could do this type of thing with a list, but I have to iterate from the beginning until I find what I'm looking for. And that's actually one of the reasons why lists are a bit slow. Okay. But again, it's something that we cover in another course called Algorithm Analysis and Data Structures. It's a different type of data structure and it uses different algorithms for signing things. Okay, so why use dictionaries? Okay, first of all, they're really fast lookups, and you just saw how easy it was for me to find things. It's clear and readable. It's actually really easy to understand what's going on. Let me go back and put in the grades once again. Remember what I had here. Okay. In fact, grades. Yeah, let's do it this way. Okay, take a look at this. What have I got? I've got a list. No, 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 no. I'm going ahead of myself. Sorry. Let's do it this way. Name. Oh, sorry. Because it's a string, it's not an integer. I have to do this. There we go. And test one. Okay, test one. Sorry, I'm going to give you a couple of scores in here. Test one at 80 and test two at 100. Here, I'll give you a better score on that one. And I'm going to print grades at test two. Hello. Um, Sorry, I think I got something running here. There we go. I don't know why that failed. I think it was left over before. All right, pretty easy what I'm printing. I would now like to write this in a slightly different way. You see, if I had the other format that I was doing yesterday, I'll just call it GR. If I had this as a list like Abdullah and 80 and 100, if I wanted to print the score test 2, it would be GR at position number 012. All right. Now, the thing is that this is less obvious about what I'm printing than this one. You see, all that I know is I'm printing the second item, but I don't know what that is. This one, on the other hand, it's very, very clear. In fact, what I can do is I can even put it around in a different order. And yeah, everything continues to work. Okay, so here, clear the screen, run it. Everything continues to work because what I've done is instead of having like test number two at a particular location, it's actually using the name to find the item. And that is what makes my program much easier to figure out what's going on. Here, let me pull up. I've had a bunch of these things. All right, so remember my exercises I've been showing you all along. Okay, so let me see if I can pull something up. Maybe not this one, maybe. Not this one. Expose inflation, fine. Flapping, fine. Flapping might be okay. No, that was not the one. Uh, archive. Do we have anything? Daily diff. Oh, okay, here we go. Ah, perfect. All right, let me grab a little bit of this code right here and I'll put it into here so it's a little bit bigger. All right, because I don't mind showing you where you use things. You see, for example, I've got this thing, it's called link. How do I get the link? I go to the objects and I ask for the differential and I ask for the extracts link. Guess what? That is a lot more clear than say what I was doing in the daily diff in another part. Not another part. No, no, no. Sorry. Where did I see this one? Extract quiz answers. I just saw it a second ago. Fine flop. Ah, here we go. Here's another piece of code down here. I just want you to compare these two pieces of code for a second. All right, four. All right, so take a look at this one. You see, what I've done is I've gone to item number 29, item number 64, item number 66, item number 80, item number 81. See, that's not clear what I'm getting. And literally, I had to go through and I had to count things. But instead, if I am using dictionaries, it's a whole lot easier to find things. For example, this has to do with the creation date. This has to do with the download link, right? So by using names rather than numbers, it makes your code a lot easier to understand. This is one of the big reasons about why dictionaries are so important because you can refer back to data and it will make a lot more sense. Okay, and it can really make your program a lot easier to see. The example that I provided here is, okay, if I ask you what these three pieces of information mean, okay, somebody will look at this and say, well, that's somebody's name. That's fine. But what's 3.4 and what's 21? I have no idea. But if you look down here at the dictionary equivalent, yeah, Ahmed is definitely the name. The 3.4 looks like a GPA, and the 21 appears to be an age. Just give me 1 second here. Okay. All right. There's nothing to do with this course. All right. Perfect. So it really does make your programs a lot easier to understand rather than these very abstract comments about lists. So it really does become important. Oh, and by the way, they're used heavily by pretty much every library that's in existence. Now, a couple of things about this. The keys have to be unique. In other words, kind of like a set. The keys must be immutable, which means that they have to be either strings or integers or tuples, but you just can't have a list. Don't you never want to have that, so don't worry about it. The values can be anything at all, including other dictionaries, which is actually really cool. And when mixing types of keys and values is allowed, but of course, if everything is the same type, it's easier. So again, if I show you down here, probably this example makes a lot of sense. So the values can be anything. So you can see here for this student, I've given them a name. The grades happen to be a list of grades. I can't tell what the grades stand for. But down here, the profile, I've put a major and I put in what year they happen to be in. And of course, when you see the curly braces, yeah, that's a dictionary as a value to another dictionary. And yeah, here's where things become really, really interesting. Okay, how are we doing? 34. Okay, then we'll have to go off and we'll have to make some, yeah, because that's the final slide. So I have to put together like a little bit more interesting things, okay? And what we'll do is we'll use my little grade lookup information and it'll actually give us a really good start on the next set of slides. I think I've removed too many slides from this. Okay, so the in operator we've already done. Okay, the del, okay, you can see here, here's how you remove something. And there's also this get operation, which doesn't crash. Okay, but let me get back over to here because I'd like to pass in some more information just to look up some stuff. So let's put a student, well, customer. Okay, we won't have a student this time. We'll stick a customer so I can make up more information. Let's put in some stuff about this customer. Okay, name, Ali. Phone number. Okay, here we go. 555-54444. And we're going to put in some other things like maybe it's a bank customer. So maybe they've got a credit limit. Okay, and their credit limit is 60,000. What else could we have in here? Let me think. Okay, address. Okay, zone 100, street 45, building 10. Okay, here you go. So here's a whole bunch of stuff about a customer. All right, so again, what would we use this for? Well, to be able to find some information about people. So what I'm going to do is I'm going to say property. Hmm. Okay. When we have a list of these things, it's a lot more interesting. All right. But in case, we'll just do a repeat of this. Oh, I shouldn't use a property. I'm just going to call it prop, abbreviation for property. All right. I'm going to ask for an input. What do you want to know about the customer? All right. So I'm going to do exactly the same thing that I've done previously. I don't know why that indents. Oh, because I have put a double quote here. Okay, so here's what I'm going to do. The value, I'm going to go to the customer. I'm going to ask for the thing called a prop, and I'm going to print the value. All right, so what do you want to know about the customer? I want to know their address. Perfect. All right, what do I want to know about the customer? I want to know their phone number. Excellent. Really, the only thing that's left is it would be a lot nicer if I could look up some information about a whole bunch of different customers. Okay. So this is where things start to become a lot more interesting, is not when you have just a single customer, but when you have a whole bunch of customers. And now things will start to become a lot more interesting. And that's actually the topic for the next set of slides. But I think because I'm still sitting around 10 minutes to go. I think I'd like to get started on the next one. And hey, it can be nice because we can finish things up maybe a little bit early again, kind of like what we did not last night, but the night before. All right, so here's what I would like to do. You see, on a real system, you wouldn't have just a single customer, you would have a whole bunch of customers. All right, so instead of having customer, I'm going to have customers. All right. Ooh, how many customers? All right. Well, here's what I'm going to do. All right. I find ChatGPT is really, really good at this type of thing. So here's what I'm going to do. Here, I'll even be honest. I'll let you see what I'm typing. Give me 10 customers for a Python program where the customers are in a list and each customer is a dictionary with a name, phone. What else did I put in here? A name and a phone, a credit limit, and an address. A credit limit and an address. Okay, I find that ChatGPT is really good for generating sample little data like this. So here we go. Here's a Python list with 10 customers. So while that cranks along in the background, you see what I'm going to do is each one of these customers is going to be a dictionary. Okay. And then I'm going to have another dictionary for the next customer, another dictionary for the next customer, et cetera, et cetera, et cetera. Wow. And ChatGPT is brutally slow because it hasn't even finished one yet. Okay, fine. When we get about five, I will put a stop to it. Okay, so sorry, I wasn't expecting it to be like brutally slow. Okay, now it's getting better. You see, this is actually one of the big problems we have these days, I think, which is going to be the big limitation in the world of AI. In order for AI to be quick, it needs a lot of computing resource. A lot of computing resources burn a lot of power, and power, of course, costs money. And power generally also causes some environmental issues because, of course, we're often burning fossil fuels and so on. So I think this is actually going to be the limitation of the world of AI. Even though it does a lot of really, really cool things, it is actually going to cost. I think it's going to cost kind of the environment a lot of stuff. I mean, this is not supposed to be talking about political things like this, but I think that's actually going to be kind of more of a limit. So let's just call it a limit. All right, so here's what I'm going to do is I'm going to grab a few of these. So it's still busy cranking along with some things, but see what I've got here is I've got a whole bunch of customers. Every customer's got a name, they've got a phone number, a credit limit, an address, blah, 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 blah. And that's the end of my list. So what I've got is print customers. There you go. Here's a whole bunch of customers. This is not very useful because there are too many things and it's not really well formatted. What I want to do is I want to be able to search for something based on the name. So here we go. I'm going to ask for the name input, what customer to find. Okay, so I'm going to ask for this. Now, unfortunately for me to find the customer, what I need to do is I need to go through for cust in customers. Now, I'm just going to do a print. Oops, here we go, print cust. If I run this, okay, just don't worry about this. What's going to happen? Customers. That's not the first time I've done that. All right. Doesn't even matter what I type in here. You see, what it's going to do is it's going to go through each of these customers. It's going to print it. I don't want to print it. I want to find out if cust at position name is exactly equal to the name. Then I'm going to print cust. Okay, watch this. If I search for Deanna King, which I can see right here, okay, see what I get back. Sorry, I need to press enter. There we go. I get back exactly the information I'm looking for the one customer. And it is more or less well formatted so I can see what it looks like. Printing a dictionary directly, however, is usually not all that nice. But what I could do is I could do something like this. I could say, okay, the name of the customer is cust name. Okay, sorry, forgot a double quote. Here we go. Print format. All right, what else do we have? We have a phone number, cust phone. Okay, I will also print the credit limit. Okay, yeah, I guess it's reasonable. Here we go. Cust credit limit. Okay, square bracket, curly brace. Here we go. Double quote done. And well, okay, we've got the last one. So here, might as well write it up. The address is the cust at the address. And double quote and done. All right, so who are we looking for? We're looking for Deanna King. Bang, there you go. There's a lot of information about that one customer. All right, who else am I looking for? Okay, who else is in here? There was somebody called Alice Johnston. Johnson. Okay, there you go. Alice Johnson, 123 Maple Street, Springfield. Hey, Springfield must be, that person should have had Simpsons in here. It should be Alice Simpsons or Bart Simpson. Anyway, that's fine, but they are in Springfield. Excellent. And of course, if I search for something like hello, well, it doesn't show me anything at all because guess what? It didn't actually find anything. All right, so there you go. There was kind of a really cool use of having a list of dictionaries. When in fact, what you'll find almost everything in your courses and all the time will almost always look like this. It will be lists of dictionaries. You use the list to have a big collection of a bunch of things that all look the same. They don't have to be the same, but they do look the same. And each one of these things being a dictionary makes your programming actually very, very simple. All right, now I'm going to do one extra thing, and then we will end up taking a break a few minutes early. Okay, and we'll reconvene a few minutes early as well. I'm just going to print customers at the very end. Okay. Um, Fiona Lee. That's the very last one. All right. So sorry. I should also, I'm just going to print dash, 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 dash. The only thing I'm doing that for is just to make sure Fiona Lee, just so I can see the difference. So this is the output of the program. I'm also printing everything again. All right, what could we do with this? Okay, to give you an idea of the type of power that we have here is new limit. Int input, what limit do you want to give? That's going to be an integer. So when I find this information, instead of printing the information about the customer, I'm going to go to the customer at the credit limit, and I'm going to be set it equal to the new limit. Okay, so what am I doing? I'm finding information about a customer and printing it, but I'm also changing the credit limit. So watch this. We go off and we take a look at Fiona Lee. All right, what limit do you want to give? 40,000. Bang. So when we printed the credit limit, of course, was 40,000, but more importantly, that very last entry right here has gone from 8,000 to 40,000. And if you're looking at this and you're saying, hey, this kind of looks an awful lot like a database, because I did have a question about databases either earlier today or yesterday, yes, this is exactly the same thing. So now we could go through and we could remove things based on some information. We could update information. Of course, this doesn't modify what's here inside my program, but it does modify the contents of the variables in memory. Okay, and yeah, we use this all the time. Okay, so this is a very, very common technique. If I show you again back to those initial programs that I often work with, you saw my find flapping and the transferring the data. These are the types of operations that I'm doing. I'm taking the data from one system, I'm doing some manipulation, and I'm putting it somewhere different. The thing that I'm not doing here, although I'm modifying it right here, I'm not storing it back anywhere. And that's really the thing that's missing. Well, for that, we would need to have some kind of a database or a file, and that is outside the scope of this course. All right. So as I said, this is kind of like the beginning of what we're about to do in the final exercise set, which I've called complex data structures. Now, I hate to say this, but when I take a look at the examples that were given for the test, and I will show that at the beginning right after our break, I said that I would find a copy of the mock test. I will scan through and I will show you that they haven't really asked too much about this. And I guess it's fair because it is an awfully quick course. But, at the end of INFS 1201, which is really what this course is based upon, basically what we want is students to be able to do this type of manipulation, iterate through a list of dictionaries and update some of the dictionary information. Okay, because that really is what you end up doing. That's a lot of what I do in all of the things that I'm dealing with when I'm running programs to either do some analysis about how students are doing or to update how students are doing. These are the types of things. So very, very yeah. Okay, so perfect. That's exactly the question about the mock exam. I will show you that in 10 minutes. Okay, so let me take a break. You guys can have a break. Usual thing somewhere in here. I've got a 10-minute timer. Okay, and then I will show you, and then I will give you my opinion about how close it is. And actually, the good news is it's actually pretty close. Okay, so here you go. Here's the 10 minutes. I will be quiet while I go grab one more sip of water for our final slideshow. Okay, but I will start with the mock exam. And if I don't, please leave a message for me and say, hey, you forgot this. Okay, see you in 9 minutes and 40 seconds. Okay, I guess we're slightly ahead of schedule because it's 5:58, but that's fine. Okay, so here we go. It was 10 minutes. All right, first thing up. So here we go. Mock exam. You don't have to open it up in your screen. I'll open it up here in a second. All right, so it's in here. If you go to the table of contents under content in D2L, right down at the bottom, there's something called mock exam. I've got a copy of it open already. Sorry, it's on the other screen. Here we go. All right, so it says final exam. So at least well, it does say mock exam, so I guess it's the one that is supposed to be given. All right, so give you some ideas about the types of questions. So remember, I showed you yesterday there were some multiple choice questions or fill in the blank, something called syntax errors and some very minor programming questions. So to give you an idea about what's going on here, which the following is not a valid name in Python. Okay, well, I mean, you could obviously try these. Excuse me. Here we go. And it would be this one right here, which is a problem because variables are never allowed to start with a digit, and that's true of any programming language. All right, so there's a bunch of things in here. Sometimes it might be things like this. Sometimes it might be, hey, what's the output of the following code? So you see that S is equal to Apple, and it's asked for S from 1 to 4. And of course, well, the question is it the first three things, the first four things? From 0 to 4, from 0 to 3, which is it's the whole thing. Okay, so you can work that one out, some slicing, and it goes on. So there's these types of things. There's a fill in the blank. So in this case, they said, okay, well, what's the magic thing that you would end up doing? Like, for example, um, apparently, so they didn't do a good explanation to this one. It should have said that the user is trying to make sure that people are at least 18 to vote because you don't know the answer to this if it's a greater than or equal to. Okay, but this is the type of thing. So there should have been an extra comment in here. I will make sure that if a question like this pops up in a test, it's very, very clear what needs to go in. Like for example, this one right here, you have 1, 2, 3. If you want to put 4 into it, what would you put right here? Well, the magic word is append. You, please don't expect that it happens to have exactly the number of dashes because if I'm doing, I might just put 20 dashes. All right, but anyway, so it's append to add something to the end. And unfortunately, no, there is no solution. Okay, but what you could do is you could certainly on any of these programs up here, you could always toss it into an interpreter and find out what does it show up, so you'll know the answer. The fill in the blank, I guess you could always copy and paste it in the chat GPT and it should take a guess. And if it doesn't make any sense, by all means, send me a message and saying, hey, is this the right answer? Is this the right answer? Again, send by email. I'll certainly do that. All right. So some debugging questions. So there was a little problem. So right here, each snippet contains an error. Identify and correct it. Well, if you remember, if statements need to have colons at the end. Let's see, 10x is bigger than 5. I guess that's probably the only one. That was pretty simple. Like, so there could be some things like this where maybe some things are missing. Like this one right here, I'm kind of guessing, well, if you were to run this, you're going to see 0, 0, 0, 0, 0, 0, 0, 0. This is definitely not a counted loop because we're missing the count is equal to count plus 1. Okay. But again, if you're uncertain about these and you want to check, no problem, send me the email. Okay, so that's no issue. And then there's a little section on short programming questions. So they ask you to do a factorial. There's no funny things in here, and there's a list or a string reversal. And I showed you how to reverse a string in one of the examples. Now, the thing that's kind of missing from this, okay, so first of all, there was a question, how similar is this to the main exam? And I'm going to describe it as very, very similar. Okay. A couple of the questions that I just saw here, I think the exact question or something that is almost identical shows up in the final exam, or at least it did last time. Okay, so there's a good news. I think there was more questions in the final exam, but they didn't vary too much from this. What I think, like in this, yeah, basically everything. Okay. Oh, sorry, that's a different question. I'll answer that question in a second. So sorry. Okay, let me continue. Next one up. Okay. Do I think there's things missing? And the answer is yeah. I've spent quite a bit of time and I explained that lists are really important and dictionaries are really important. And unfortunately, I didn't really see a lot of questions. I'm not going to say about anything. I'm just going to say it's it's I find that there wasn't enough, but I'm not going to go out on a limb. I'm not going to do anything different compared to what was done last time, just to be completely fair. And I'm going to say that there wasn't really a whole lot. Maybe there's some MCQs, but I don't think they asked any programming questions. Again, don't quote me on this. All right, so now let me get over here and take a look at the question. So, will it be allowed to use the Python interpreter during the exam? Well, this would be kind of silly because if I ask you this question and I give you an interpreter, that's not a question. That's just copy and paste and run. So the answer is, while you're doing things like that, no, you're definitely not getting anything. So sorry, you have to know these. Okay. What we have done in our courses here is for these MCQ type questions, the fill in the blank type questions, the debugging type questions. We never give an interpreter. For programming exercises, we usually do. Okay, this way, at least you have a chance to try writing the code and to make sure that the code is correct. So the answer is yes, you get it, but not for everything. Okay, so that's normally what we've done. I haven't talked to the department head about if this is the way how we do it. What they did last time is I think we just had the students write the code here directly. And the good news is that when you write code in pen or pencil, if you make little syntax mistakes or spelling mistakes, we don't care. You don't penalize it as long as you get kind of close. So you're allowed like some little tiny errors without problems. But obviously, if I give you an interpreter, then I am expecting that there are no syntax errors. I am expecting this. I have to talk to the department head. Okay, what I'll do is I will send a message to him asking if we want to do this. And if he says yes or no, I will post a message to D2L. I'll try to do it tomorrow as long as he answers tonight. I will do that, and you can check and we'll know exactly what's coming if it's only on paper or if it's going to be like electronic where you get a chance to answer something. So you're absolutely right. It is better. Okay, so Rashid has said that it's better if you have an interpreter and it is faster. Yes, it certainly is. But at this point, you can't answer these types of questions because we can't ask those types of questions. It has actually been a long debate here in our program about whether or not we give students access to interpreters during tests. And I will tell you the two sides to it. Number one, do we want to do it? The answer is yes, we actually do. Okay. Because I don't really like a lot of these things. A few questions like this is all right, but I don't like a lot of them. Writing the programs is much, much better. However, and again, this is not after you guys because you might be different, but we have a lot of problems with academic dishonesty. And as soon as you put anything into a program and onto the computer, it's another place where we have some problems. Okay, so that's quite often why we have some of these types of issues. But I completely agree. I would really like to give the interpreter for everything and say, here's 5 programming questions. Please tell me, because it's a really good measure about whether or not you can do things. But of course, now with ChatGPT, obviously the course isn't about can the student copy and paste an answer from ChatGPT. The question is whether or not you can do it yourself. All right, but in any case, I will get back to you when I get an answer from the department head. Okay, so it was Dr. Saifuddin, who was actually going to teach the course originally. If he says, let's do it on computer, I will let you know this is what's going to happen. And if it's going to be on the computer, I will make the mock exam available on the computer. Okay, so I don't just mean in this PDF format, but what I will do is I'll put together a quick little video to show you how to take a test in D2L so that you guys have seen it so it's not a big surprise. I have a feeling that if you're taking other remedial courses like the data science and AI one, and even the cyber one, I have a feeling that they will probably use D2L as well. So I will provide at least a quick little tutorial. So I'll record a video to show you this is what it's going to look like, and then I'll let you guys do this. So the good news is we still have like 20-ish days, I guess it's 19, please just continue to check back into the D2L course shell. Just look at the news items. Okay, so even though our course is finished, just check that for like once a week to see if I've added anything else. And exactly what I've said before, if you're bumping into problems and you want some help with something, send it as an email. I have no problem helping you over the next few weeks so that you're ready for this. But as promised, the actual exam really wasn't that much of a stretch compared to this mock exam. So that's the good news. And I will try not to vary too much from it. Okay, let's get over to here because I've got one final set of slides to talk about, which is our nested data structures. Okay, so what do I mean by a nested data structure? Well, first of all, what is a data structure? Okay, a data structure is a place where you store information. We have seen a bunch of data structures already. I would call them primitive data structures because they're very, very elementary. They're built into Python, and those data structures are a list, a tuple, a set, and a dictionary. Okay, those are data structures. The word nested means one thing inside another. And we have actually just seen a nested data structure right here. This is a list of dictionaries. That's a nested data structure. These things are very, very important because this is how you actually deal with real life. So storing real life data benefits from use of complex data structures. Unfortunately, it's more difficult. For example, I might use a dictionary to track the students in a course so that it's quick to find the students given their ID. Each student, however, likely comprised of a name, some contact information. It's pretty much what I just did. Okay, except that I had some customers. Each course would be a course code, a semester, and a grade. Being able to work with lists of dictionaries and dictionaries filled with dictionaries, this is really important. Remember, I keep saying this over and over again. A lot of you, or I'm assuming that some of you will end up in the program for data science. And of course, what will happen is all that stuff, even though there's lots of libraries to help you. When you load some information, it's going to come back in basically lists of dictionaries and dictionaries filled with dictionaries. Okay, so these things we use all the time. All of the data that you saw in my examples that I've been providing, I go to a website and I download dictionaries filled with dictionaries. I download lists filled with dictionaries. These are the most common things. Okay, so lists of dictionaries, I'm going to describe it as a very common and useful pattern, and it's used where each item has multiple properties. For example, here's a bunch of students. Each one has an ID, a name, and a GPA. So it's ideal for storing things like students, products, readings, customers, etc. So often it's processed using a loop. Okay, in fact, we did that. We went through each item in the list and we did something. We updated, well, we looked for something and then we updated the credit limit and we just printed out some information. So you have data about a lot of things where each item has a number of properties, often processing involves iterating through the list and processing one item at a time. So that's exactly what we did back here is I iterated through all the items in the list and I looked to find out whether or not it was the customer I was interested in. If it was, I printed out the information and at the same time, I changed the credit limit. Normally, I would do this inside a function. It would make a lot more sense. Okay, but these are the types of things we're doing. So here's a list of students. Okay, I won't bother running this one. Okay, because it's actually pretty similar to what we've just done. Or do we do it? Okay, you know what? Yeah, fine. I guess it's nothing to copy and paste it and just drop it in here. Okay, we get, except there we go. So what I've got is I've got a bunch of students. All right, I didn't format it as nicely as I did before, but you can see here that I've got 1, 2, 3, 4, 5 students. And what I've done is I've said, hey, academic honors. What's academic honors? Well, those are students who have a GPA higher than 3.5. I suppose what I better do is to print it out. So you see, if I run a program like this, what I'm getting is I'm getting the list of IDs who happen to be academic honors students. The reason why I send it back as a list is because, well, I knew I was going to have more than one. All right, so take a look at what I did. I created a function. Of course, I created a function. It's to make down here a lot easier. I gave it a doc string. Okay, so I could know what it's doing. And I started off a result set as being an empty list. And I said, go through each item, each student in the student list. If the student's GPA was bigger than 3.5, I appended the ID, just the ID of the student to the result, and I returned it. And then, of course, I went through and I printed it. Hey, excellent. So there you go. This is a very, very typical thing. You iterate through a list of dictionaries, you look at one property, and you return something else. Okay. Yeah, it's a very common thing. I mean, we did something similar to this a few minutes ago when we printed out the customer information. Okay. So a very, very common type of approach. Game number two. Okay. So this one's a little bit different. This was an example of a game. All right. So what I'm going to do is I'm going to copy some code. And sorry, this one got broken up into a couple of pieces because it was a little bit big, didn't quite fit in one. And here's what I want to do. Okay, I am just going to put some spaces here just so I can hide everything. Okay, you can still see it. Okay, what I've got here is I've got a game. Okay, so I mean, it's not a very fun game. It's got no graphic interface, but it could be the start. So you see what I've got is I've got a whole bunch of characters. Every character's got a name, they've got a class, they've got a level, and they've got an amount of health. Okay, well, you know how this works is when you hit a player, okay, what happens? Well, some of their health goes down. So what I'm doing is I'm saying, okay, go off and hit the player, okay, called Luna, and inflict 30 points worth of damage. And of course, then this will come back with whether or not they are okay. All right, take a look what happens to hit the players. What I do is I go through each of the players. Okay, there's my for loop iterating through everything. And if the player's name matches what I'm searching for, I take the health, I bring it down by damage. And if the health is less than zero, I make it equal to zero because we can't have negative health. But then I ask the question, if the health is equal to zero, I return false to say that the person is no longer alive. Okay, so it's not much of an exciting program because I just hard coded some values. But you can imagine, what would I do to turn this into a real application? Well, what I would do is I would probably have a GUI interface and I might have a mouse. And when I click on it, I swing the sword and I inflict 30 points worth of damage on this player. And then I find out whether or not the player should continue to live and what their health happens to be. So you can see here that Luna's health ended up at 50. It used to be 150. No, sorry, Luna's health was 80, and now it's gone down to 50. And then when Kiro, okay, which was right here, 95, when they got 100 points worth of damage, you can see that their health came down to zero. And of course, now what I can do is I can show an animation of the person falling to the ground. Okay, and I know we don't do really exciting things like that in this course, and you probably won't do exciting things like that even in your data science and cybersecurity stuff. However, you get the idea about what you could do. And yeah, being able to iterate quickly through the list of players to find the player you're looking for so you can do something, this actually does exist inside the games. Okay, other than you probably don't use it as a list because lists are actually kind of slow. You're better off using it as a dictionary full of dictionaries. Okay, so there we go. There's a second example. Okay, the final thing then. So final thing, I think we're going to be finished really, really quick. I'm going to have to do a couple small examples, however, but then I think this is actually like one of the final things we're going to do. All right, so that's fine. I don't mind finishing this up a little bit early. Okay, so here we go. Dictionaries filled with dictionaries. Now there's something that we haven't done. We've had list of dictionaries. Okay, but dictionaries of dictionaries. Okay, the way how to deal with this is to come down here and look at this one. Okay, I'm going to put this away. Sorry. Go, go, go. I'm going to copy all of this. All right. This is not very much different than what we just had. This is a list of dictionaries. Okay, you want to find some information. Let's get the GPA. So I'll call it GPA. Somebody has written this nice little function here called get GPA. In order to get GPA, I need to pass in a list of students and I need to pass in a student ID. Student IDs for some reason here are strings. So I will use that. And I want to get the GPA of this student and I'm going to print GPA and I'm going to run it. So is that this person's GPA? And the answer is yes, it is. Okay, there you go. So that's how you find something. I'll just do a quick little test for this one. Okay, here you go. It's 1.5. We can make the program a little bit more interesting by asking the user, what student ID would you like to look up? And then, of course, we can pull up the GPA for that student. Okay, excellent. Okay, so here we go. Actually, I just want to make a note of something because I'm realizing that something is missing on my regular slides. Generating through dictionaries. I know that that's missing. I need to fix something. Okay, you guys are fine, but my regular course isn't. All right, so here we go. Now, how does this whole thing work? Well, when you call get GPA, you jump up to the function, and here it is again for student and student lists. You go through each one. If you find the student that you're looking for, you return the GPA for that student. It's actually pretty easy. And remember, this is how we were asking earlier. How does it find something? Well, it just goes to the property called GPA and it returns it. Very, very nice. That's a great way. However, I've got something I'd like to talk about. There are 5 students. Okay, how long is it going to take a computer to go through 5 students? Well, it's going to go pretty quick, actually. It's going to happen within milliseconds. It's going to be able to iterate through all 5. Now, the thing is that on a real system, okay, how many students do we have now at UDST? Well, all of the students who used to be around at CNAQ, by the way, yeah, you're still here. And I know I've got students who got really small ID numbers. So yes, all those IDs, everything that's ever been at the institution since we began are still here. Now, how many students is that? Now, I don't actually have an exact answer, but I have a feeling we're probably somewhere around 50 to 60,000. Okay, just kind of a rough estimate. And now, can you imagine how much time it takes to go and search through 50 or 60,000 students? This is obviously going to be kind of slow. Well, it could be slow. And I've already showed you what happens if you're searching through a big long list. Yes, it actually does take more time. One of the things that often ends up happening with the world of dictionaries is we change things up a little bit different. Take a look at the code that I've written here. It's exactly the same piece of information. It's exactly the same program. Okay, here we go. Paste it into place. But you'll notice what I've done. Instead of having this as a list, I've turned it into a dictionary. The key of the dictionary is a student ID. Okay, now remember something that's very important about dictionaries is keys can never be duplicated. Well, that's fine because student IDs are never duplicated. Okay, so this makes a very, very good key and it makes a very, very good property to look things up. Because now, if I have not a student list, oh, it shouldn't be called a student list. It should be called a student dictionary. That would be much, much better. So here, student dictionary. Okay, that would make life a lot better. It would work called a list. It would just make less sense. Take a look at what's happened. First of all, does it work? GPA is equal to get GPA students, and I'm going to search for this student right here. And again, I could ask the user to type it in. I'm just going to print GPA and take a look. It still runs exactly the same way. If I ask for something that isn't there, I get back a none. If I ask for, say, this one right here, okay, it still works. I get the 3.9. Now, here's the thing that I want to point out. So it works exactly the same as what I had a second ago, but I want you to take a look at the function get GPA. Notice what I don't have. I don't have a loop. I don't have to go through all of the students. All that I'm doing is I'm saying if the student ID is not in the dictionary, return none. Otherwise, I go to the student dictionary directly with the student ID and I pull out their GPA. No loops. Now, one of the things about not having a loop is even if I have 60,000 items, I don't have to go through all 60,000 things. Dictionaries work. They're very, very clever. They use things called hash tables and so on. But this lookup right here takes place basically instantly. And remember, I showed you a difference between a list and a set, and you saw how much faster sets were. They were pretty much instant. It was zero point 0.1 milliseconds, even for a really big thing, versus 16 seconds for a list. By replacing lists with faster things like sets or dictionaries, because dictionaries are exactly the same way, we can really speed up the program. The second thing is this is much easier to write than setting up a loop. Okay, it can be a little bit more complicated because you have to remember what it is that you're looking up, and you do have to remember before you use the subscript operator to check and make sure the item is there. But saving yourself a loop actually saves a lot of time. It saves you time in programming, it saves the computer time in actually running. I use these all the time, especially if I'm looking for things over and over and over again. Um, yeah, I could show you examples of things, but I use dictionaries whenever I get some really slow behavior. Like quite often, what I'm doing is I'm searching through big pieces of data looking for things. I used to have a process, for example, that used to take about 5 minutes to run. And basically, it was taking too much time. And I said, you know what? I'm just going to turn this over to a dictionary. The programming was more difficult. Maybe it took me a couple of hours to get everything correct, but then I could run exactly the same analysis within a couple of seconds rather than 5 minutes. And yeah, I know it's only 5 minutes, but if I'm doing it once a day, trust me, a couple of seconds is better than waiting for 5 minutes each time that you try to run it. And this is one of the reasons why dictionaries are really kind of superior than lists. The downside is you can't have two things inside the dictionary with the same key. Okay, but that kind of makes sense because, well, if you have students, every student ID is going to have their own unique ID. For those, again, who've looked at some stuff dealing with databases, yeah, we're talking about primary keys. And this is one of the reasons why most databases require a primary key because they use techniques for storing information on the hard drive, which is very similar to what we're doing or what Python does for storing things like dictionaries in memory. Okay, let me get over to the slides again. Okay, so here we go. So you don't need a loop, and that is really, really clever. If you don't need the loop, it really makes things a lot better. Okay, now here's the one downside to things. You do need to check each time before you actually go and use a subscript like GPA. You have to make sure that it's actually there. If it isn't there, you end up with a crash. Okay, so um, if I remove this thing right here, that if statement, and I run the application, it works perfectly fine here. Clear the output so I can show it actually does work. It's not just leftover. If I ask for something that isn't there, I do get a crash because I didn't check in advance. Okay, so you have to check in advance, and that's why this if statement right there was there in the first place. If the student ID was not in the student dictionary, send back a none. Otherwise, go and look up the information. So now I get back, sorry, if I ask for something that isn't there, I get back a none, which is at least a little bit better. Okay, all right, so there we go. And doing 6:26. Woo. Yeah, we're done actually really early. Okay, well, I guess that's probably okay because it looks like the next one is this one here, list of dictionaries versus dictionaries of dictionaries. All right, the one thing that I forgot to cover, okay, and I know it's not in the slides, and that was the thing that I made a comment about, so I have to take a minute to describe something, okay, because I think it's really important that I cover this. And I don't know, maybe I accidentally hit delete on one of the slides where it was covered, or maybe it's just missing and I've got to get it put in for my other section. Okay, I want to make this as simple as possible. Let me get rid of the function. Okay, here we go. Students. Okay, print students. Okay, it's a mess. Okay, it really is a mess. You see everything. You know very well that I have been showing you things that look like this. I say, okay, if you want to iterate through and look at each individual student, can you do it? And I showed you how to do it with a set and a list and a tuple. All right, I'm just going to say for X in students, I hate the variable X, but it's a good way to get us started. Print X. My question is, What's it going to print? So here's the first hint. No, it's not an error, but the question is, what's it going to print? And I know what you're expecting. You're expecting to see each of these items. Okay, well, unfortunately, it's a little bit different. When you iterate through using a for loop on a dictionary, what you end up getting is exactly the keys. Okay, is exactly the keys. So it isn't X, but what it is, it's the student ID. That's what you get back. So here you go, student ID. That's better than X. Okay, here you go. So student IDs. Now, what can you do with a student ID? Well, you could do something like this. You could go to the students and you could ask for the student ID, student ID, and you could ask for the name of the students, except that you have to close a parenthesis. Sorry, here you go. So now what I'm doing is I'm printing out the information about the students. Hey, if I don't print this one, there you go. There's a list of just the students. Excellent. I can print them out. I can do other things with them. This is a way how you iterate through a dictionary. There's another one which is also very, very useful, and we use it all the time, and that is you can stick in here something called dot values. Okay, I'm going to have to call back. I'm going to have to call it X again for a second. So print X. Take a look what happens when I iterate through the student dot values. I get exactly the values. I don't get the keys anymore. I just get the values. And sometimes that can be useful because, okay, so what's this information? This is a info, student info, and maybe I'm just interested in the GPA of the student info. There you go. There's how I could pull out the student GPAs. What if I need the student values plus the keys at the same time, the IDs? Well, what I can do, again, I'm just going to call it X for a second. Okay, there's another property called items. Take a look at what items are. Items gives me both the keys for the student ID, as well as the values. And you'll notice that it appears in a tuple. That's what the parentheses are. So what this is the ID. I'll call it SID for student ID and being lazy, and then the details. And this is often what I end up using. So SID and print details. That kind of gives me both. So the ID, the SID happens to be the first part of the tuple, and the details is everything else. So I could use that to go through and pull up some information. And I could do some interesting things like give me a list of the names of the students whose GPA is less than 3. Okay, so I could do things like this. I could include their ID plus their name plus their GPA in whatever format that I wanted to use. So I know that this dot items and dot values are missing from the slides. And I'm sorry about that. I think I may have just accidentally erased one extra slide because there's a couple of slides that I dropped out. All right. One final thing. I forgot to cover this, so I got two extra things. OpenStax Python. All right. OpenStax is the actual book that I am using for my INFS 1201 course. And it's basically a free book. It's not what I would describe the best book in the world, but it's not bad. It's not bad. And it is open source. It's free. By the way, if you did a Google search and you find something else and you find somebody's textbook online in PDF format, I'm supposed to say that that's illegal. You're not allowed to do that, but yeah, don't worry, okay, because I know everybody does this. All right, but in any case, everything will be in here. So if you're looking for more information about dictionary operations, yes, I know it's completely free. You can read through this, and there's some little videos in here as well. There's some little concepts and practice about some sample question, or sorry, some dictionary questions. There's talk about dictionary mutability and so on. I've been trying to align my courses so that it matches this. The downside is, let me pop open something because I did promise one extra item. Computer programming. Okay, this is my INFS 1201 course. Student resources, we have the OpenStack Python book. That's the link that I just showed you. And I also have this thing called book appendices. I'm just going to submit feedback. No. Download, sorry, got the wrong one. All right, what this is a list of additional things that I know is not covered. Okay, like for example, in the OpenStax textbook, there's nothing about sets. So what I've done is I've written up a small piece of information about sets. This goes hand in hand with the OpenStax textbook. Sorry, I should have made this available on the first day. All right, but here you go. There's stuff about tuples. There's stuff about well, okay, searching and sorting. Sorting, yeah, we don't cover it here. Sets are definitely covered. And okay, so I guess those are the only interesting things. So additional list operators, the tuple information, additional tuple information, and the sets. Hey, this could be of some use. This needs to be put for you guys. CPIT 1020, content, Python reference guide. I guess that's a place where I can put it. So here we go, upload a file, my computer, upload, and I guess it's appendices. Yeah, that's the one I just downloaded. Here you go. And appendices, not that way. Header properties in place what I'm looking for. So here we go. Additional information to go along with the OpenStax Python book. You would be interested in sets, tuples, and was there something else? I can't remember what else was there. Sets and tuples. Think that's it. Yeah, because these other ones, these are things that we include in our other course, but they're not part of this one. Okay. All right. So there you go. Sets and tuples. Okay. So there you go. That's something that I've written. All right. The final thing then. Okay. 634. Hey, we're doing all right. That is Python Reference Guide Part 2. Okay. And as promised, if you remember, there was a Python reference guide that was given the other day after the first two classes, is what I was told to do. Cover two classes, give the first part, cover the next two classes, and give this one. So this is the continuation. This is part number 2. I've put a copy of that into D2L already. And what it is, some background on functions. Function parameters and return type, variable scoping, the global keyword. We certainly covered that. Okay, here's something that we didn't do. We didn't cover functions that are defined inside other functions. I think this is an incredibly bad idea. Okay. Python allows it, but I think it's really bad. I don't think, for the most part, an introductory Python course should be worried about putting functions inside other functions. I never do this. I usually take marks off if students try to do this. I'm just going to say, don't worry about this, and I will make sure that there are no questions about nested inner functions and closures because I don't like it. I don't actually agree with it. I'll make sure in the final exam we don't have anything because I really strongly believe that we shouldn't be doing it. All right. Section 2 is about lists. I've included the list methods here. We've talked about all of these. We talked about list slicing. We talked about nested lists. I prefer putting spaces on them, putting this on the next line, accessing elements, iterating through using nested loops. Okay, dimensions about rows and columns. We just talked about tuples today, the tuple methods, the tuple unpacking. I did cover that. We talked about sets and how to. Okay, I didn't do a demonstration of removing, but I do recommend you try that. Okay, we talked about the set operations, about the union, the intersection, and the difference. There's also this thing called a symmetric difference. I'll let you read about that. Okay, it's not something that shows up very often. All right, we also talked about basic dictionaries, accessing and modifying, removing elements. Here's the thing that I missed. Okay, I don't know what happened to it, but I've gone through now and I've shown you about the dot values, the dot items. There's also something called dot keys, which guess what? Displays the keys. But I did that. You don't even need the dot keys. You can just say indeed. It still works. We talked about nested dictionaries, and then there's some exercises in here as well. So yeah, we've done everything, and then there's some solutions to the exercises. All right, so that's the stuff you will find under Python Programming Reference Guide Part 2. This is my appendices, which I will leave in here as well for additional information. Okay. All right. With that, you would be able to finish all of the exercises in the labs. Well, almost. Okay. So let me pop open the exercises from the labs once again. Now I have to find them. Okay. Those exercises, you would now be able to deal with dictionaries. You'd be able to deal with dictionaries here. I think number 16 is like one of the best sets of exercises for dictionaries, if I remember. Those are very good. All right, searching and sorting. No, it's not part of this course. Okay, sorting complex structures and files, not part of the course, and CSV files, not part of the course. So you guys can ignore everything that shows up after week 10. So right up to dictionaries. Okay, so it's the dictionaries, sets and tuples, and lists and 2D lists. Yeah, we've already done it. So you can ignore all of that stuff from here until there. Okay, you can ignore that. I'm not going to erase it because this is my portfolio for another course. I just zipped everything. I took no break. I just basically zipped it all because I didn't have time. So it's up to you guys to ignore the searching, the sorting, the complex sorting, the files and CSV files. No, that's outside the scope from here. Okay, and as I promised, the files or the mock exam is actually really, really close to the exercise or to the final exam. I do recommend you do a little bit of stuff about dictionaries, sets, and tuples, even if they're not well represented. Please, you have to see these things because you're going to have to write programs and you're going to have to deal with dictionaries and tuples uh, quite a bit through most of your other, and of course, lists. So even if the final exam for this course doesn't really expose you to a lot of it, you're going to be exposed to a lot of it. So my recommendation is do at least a little bit of stuff so that when you get into your DSAI courses, you'll be able to actually deal with the dictionaries that are coming back. And you won't say, oh, I have no idea what a dictionary is, because that is the thing that is going to that's the thing that's going to slow you down if you're not sure how to deal with it. Okay. All right. I have actually finished everything. So we're 10 minutes early. Excellent. Well, again, I have no problem finishing this up because, hey, I just make note and you say, okay, next time through, let's add the extra thing. So I know that some iteration stuff needs to be expanded a bit more, and that probably would have taken another 2 or 3 minutes. And there's probably an extra thing that I could have included. Okay, luckily, we've managed to cover all of the material. I know that this is a big whirlwind. I don't know how effective this is at running a course for 3 hours a day, 4 days in a row. I find it quite tiring, and I cannot imagine that it is any better for you. Okay. Really, I think like one of these courses, 3 hours at a time is pretty harsh. But if it was happening like over 1 week with some exercises between it would be better. But I'm not the person who designed the course or scheduled it, so we just do what we can. So now the good news is your test isn't tomorrow. Okay, the good news is that the test is coming up in a couple of weeks. You're going to need the time to go through. You're going to have to try some of the exercises. My recommendation is go through the exercises in the Python reference manual. Go through some of the exercises here. There's a lot of them. Trust me, if you can do all of these, you'd have absolutely no problem with anything that I would give you. But you don't have to necessarily do all of them. But I would kind of recommend like you grab 1 or 2 exercises from each of these sets. The way how I've structured these is the earlier questions are easier than the more difficult questions. So if you wanted to do even say just questions 1, 2, 3, that would be all right. If you're feeling really generous or really brave, go for the higher number questions because they are trickier, but of course they are trickier, which means they're going to take some more time. All right. And I don't know if you're taking the remedial courses for the DSAI and the cybersecurity. I don't know who's registered, but I know that there's more courses coming. And I know that they're going to be just as intensive, or I'm expecting that they're going to be almost as intensive as what we've done right here. So please go off, do the exercises, and I wish you the best of luck at working through the remedial course for this one. I Promise it's not going to be too difficult. It's not going to be completely different than, say, what happened with the mock exam. Okay, so that's the one thing we tried to do. And I hope that your other remedial courses are successful. And if, I guess, if you're successful, then you'll be part of the master's program here at UDST. No, I probably won't be teaching any of those courses, so you'll never have to deal with me again. Okay, because usually these courses are taught by other people. They're in different programs than what I'm involved with. I just deal with the undergraduate, all the programming stuff. So, good news is you don't have to hear me again. All right. However, for the next 2 weeks, if you have a problem, no issues, send me an email. If I can answer by email, I will. If I need to, I'll make a video, I'll post it on YouTube, and I will post it in the news item that somebody asked this, and it was an interesting question, and I will post it as well. Okay, so feel free to ask questions over the next 2 weeks. I have no issue giving you a hand with it because, well, I don't have any other office hours. So I guess the only thing that we have is to drop me an email. Okay, just before you take off, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Okay, good. I've got everybody marked down who's here. Okay, and I guess if there's nothing else, I mean, I'll wait 2 or 3 minutes to see if there's anything. Otherwise, you guys are good to go. And as I say, I hope everything works out well, and hopefully I'll see you at least around the corridors during the fall semester. Okay. Oh, okay. So cannot access D2L. Unfortunately, there's not much that I can do. Did you get back a ticket number? Because normally when you, oh, maybe you didn't. Okay. Let me see. Oh, Baker. So right here. All right. All right. Here's what I want you to do. Do you mind sending me your personal email address? Here's what I want you to do. There you go. That's my email address. I want you to send me a message there from wherever you've got access to. If you've got access to your UDST email, perfect, send it from there. If you've got a personal one, send it to me there. And what I will do is I will forward a request over to IT Help Desk tomorrow, and I'll ask them if they have processed this one, or maybe they didn't receive it or something. Okay. So if you send me a message there, if you do not get a response from me, how are we going to deal with this?
Hi.
Hi.
Yeah, I didn't receive a ticket through the email as well.
Okay, no
Uh,
problem.
I can send you an email from my personal email because I don't have
Yeah, okay.
UDST
Yeah,
email.
no problem. If you want to try that, like try that right now. If you don't get an answer from me here,
Okay.
here's what you can do. There. You can send me a WhatsApp message. Okay.
Okay.
If you don't see an answer from me tomorrow, send me a WhatsApp
Mm-hmm.
message. Like you can do it
Okay.
first thing in the morning. As soon
Okay.
as I get an email from you, I'll reply to say yes, it's done. Send it by WhatsApp, and then I will send it. So maybe there was a problem with the email. Which email system did you send it from?
IT help desk at
No, no.
UD.
Which was it Hotmail, Gmail?
No, Hotmail.
Oh, Hotmail. Yeah, okay.
Mm.
You know what? That's not
Mm.
going to work. They've got Hotmail locked down like crazy here, and they don't take anything. Do you have a Gmail account?
Yeah.
Send it from there and try.
Okay.
Okay, so send it to them
Mm-hmm.
first. If you don't get an answer like within an hour, like wait for tomorrow morning, give it till about 9 or 10 o'clock. If not, send
Okay.
me a message. And if I don't respond, send it to my
Mm-hmm.
WhatsApp. Okay?
Okay.
Yeah.
Sure. Okay. Thank you.
Yeah. Okay. No problem.
Okay, thank you.
Okay, thanks.
Thank you. Have a nice day. Bye.
Okay, thanks.